Hello everyone, welcoming you to Short of Sales classes. So, today we are looking at the IIFT 2019 Economics Entrance Paper, question number 16. If the 95th percentile of the normal distribution with mean mu and standard deviation sigma is x1, then the distance of x1 from mu is. So, this is a straightforward question from theory. So, if you can just draw the rough figure, then we can easily understand this. The normal distribution is symmetric about the mean, so here you have the mean mu, and the normal distribution is something like this. So the 95th percentile is basically the area covered till that point is 0.95, and if you remember, this value is 1.645. Okay, so clearly you can see that the option will be option number A in this case. So it is 1.645 times sigma. Alright, okay. So now moving on to the next question, which is question number 17 in our case. A biased coin with the probability of obtaining a heads equals to p greater than 0 is tossed repeatedly and independently until the first head is observed. The probability that the first head appears at an even number toss is the following. So what do you mean by even number toss? It's basically, that means it is either the second toss or the fourth toss or the sixth toss and so on. Therefore, what it's interesting to observe is, note that they are asking us to find out the probability where the first head occurs. So if I am sticking to this case where we are looking at the head occurring in the second toss, that means it's obvious that in the first toss a tail had appeared. So let us just jot down the information. So probability of head is equals to P, probability of tail is equals to 1 minus P, right? Probability of head in second toss is equals to, in the first toss a tail has occurred with probability 1 minus P, and the second one a head has occurred. The second part is probability of head in fourth toss. So in the first three tosses a tail has occurred with probability 1 minus P, and in the fourth toss head. And likewise, if you just look at one more case, probability of head in the sixth toss, that will be in the first five tosses the tail has occurred with probability 1 minus P and a head in the sixth toss. Therefore, what is our required probability? It is 1 minus P into P plus 1 minus P into 1 minus P whole cube into P plus 1 minus P to the power 5 into P plus dot 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 and so on. Okay, so 1 minus P times P will be taking common, that is 1 plus 1 minus P whole square plus 1 minus P raised to the power 4 and so on. So that is 1 minus P into P, so this is 1 minus P squared plus 1 minus P square of squared plus, so that means basically this third bracketed term is a GP with first term as 1 and the common ratio as 1 minus P whole square. So that means this is going to give us 1 minus P by 1 minus P times P, 1 minus P whole square. So 1 minus P into P out, that is 1 minus 2P plus P square. So that is 1 minus P into P, so that is 2P minus P square. So again P will be going out and we have 1 minus P divided by 2 minus P, which is basically, in our case, it is your option number A. So question number 17, option is A. Thank you.